Hi everybody, how you doing tonight? Chapter 19 is Mineral Resources. We're going to look at No Stone Left Unturned is the name of this chapter. And this chapter is going to be looking at how we're using mineral resources as part of society. These resources that we have in our earth basically surface somehow, whether it's us taking it out of the earth in the form of mining, or it exists on the surface of the earth that we go and then collect, are going to be used in many different applications of society. And today we're going to look at a little bit how this might impact our society from an environmental and sustainable point of view. Now, this idea of mining and resource management is a huge, huge field. If you do have interest in this, I suggest you take more earth sciences and mineralogy courses in the department, and hopefully you can kind of learn more about what the field is like and study and get into it more. But in this case, we're just going to look at this, how society relies on many mineral resources. You can see this picture on the left-hand side of your screen here. Right here, where these miners are actually working in the ledge cliffs to try to look for gold. They're panning out some material there to see if they can hit a vein of gold that will be worth lots and lots of money. And these workers are working diligently, and look at those working conditions. You have to ask yourself, would you want to work in those conditions? And what does it mean when they get the gold? Where does it go? How is it processed? Who gets all the money from it? And where does it end up? So all these kind of questions are going to lead to us to think about what are the implications of mining resources out of the earth, and how do they pose dangers to people, or do they? And then specifically, what parts of the world do they pose dangers in, and what type of dangers do they not only pose humans, but do they possibly pose the environmental surrounding or ecosystems, and then how are these viewed from a sustainability lens? So we're going to look at some of the different mining mining methodologies to see how these materials might be extracted from the ground, and we can also look at some of the safeguards that might be in place to help us perform this process in a hopefully a sustainable manner. So by the end of the chapter, hopefully you'll be able to understand how geologic forces shape the planet, rocks, and minerals on the earth. We're not going to spend as much time on that particular topic. We're just going to spend a little bit of time. That's more of an earth science course, and you'll get a lot more info about that in an earth science course. And in our course, we're going to focus much more on mineral resources in society and how those resources are mined and processed. Okay, so just a little bit about geologic forces, understanding that geology is the study of the earth. We'll get to that. And then we're going to look at how environmental and social impacts of mining and processing are addressed, and some of the negative impacts that occur to these communities that are performing these operations. Okay. So thinking about no stone left unturned. Well, most people don't realize that the number of non-renewable minerals used by society are quite large. Many people don't really realize what goes into things that we use. In fact, did you realize that there's gold in your cell phone? Yes, the same gold that is highly sought after, that is used as the gold standard, is also in your cell phone. So it's there. And think about how many millions and billions of cell phones there are in the world. That's a lot of that gold that needs to be pulled out of the ground and then just stuck into your cell phone. Okay, be it there's not a ton of gold in there, but there is gold in there. All right. The problem is that they are rare, it's expensive, and the extraction processes can cause a great deal of environmental damage. So, I mean, how do you get the gold out of the ground? You can't just walk down the street and grab a hunk of gold on the corner and say, hey, I now have gold. If that were the case, then the value of the gold to societies would be very, very low. But in fact, gold is extremely highly valued, so much so that it is used to support the international treasuries, okay, by literally putting gold in one bank or another, like we do at the U.S. Mints or at Fort Knox, okay? That is why it's highly sought after, okay? So the material itself is very durable. Well, I should say it doesn't really lose its shine, but it's malleable. It can be made into many different things. But we'll go into gold a little bit more. But even everything from iridium to even nickel cadmium that's pulled out of the earth to go into batteries and things like that. They can cause a great deal of environmental damage as we get this stuff out of the ground. But the problem is we need the stuff to make our other stuff work. Okay. The one of the issues is that our society has become increasingly electronic, and so to run these electronics, we need circuitry, we need copper, we need these materials that run our electronic systems in the forms of screens and speakers and wires and everything else. All right. So there's a field of research and a pursuit of study that goes and tries to understand what this resource issue is all about, and are there ways that we can develop some of these electronics and things that we use. By the way, it goes much beyond electronics. That was just one example, but some of the things we use in life, and how can we make them less expensive or less resource consumption, and we can keep moving to see how we can refine our technologies and our products to make them a little bit more less dependent on heavy resource mining. All right. Well, there's people like Dr. Mark Hersman, who are working on developing less expensive and less environmentally damaging alternatives to many minerals out there. Okay. So what is a mineral? Well, for example, what's a rare earth material and what's a metal, right? These are very kind of words that are used in technology. Used in our society. But really, what are they? The term mineral is referred to any solid chemical structure or chemical material that has a regular structure. It is used in conjunction with materials that have an economic value as well. Okay, so there's many minerals that are used and are found that aren't necessarily as economically valuable as others. But when we put the social perspective on the term mineral, we kind of see that there's this connotation of social value associated with a particular mineral. All right, for example, way back in the day, the mineral fluoride, for example, was used to, or is used to help us maintain strong teeth. So we started putting it in our toothpaste, and then some places wanted to put a bit of fluoride into our water systems, so that when we drink water, we're naturally just getting the fluoride in the water. So there's a value associated to this mineral. All right, but if you think about more of this idea of a mineral, there's some that are a bit more common than others, and the ones that are a little bit less common are called rare earth minerals. And there's basically a group of 17 economically valuable minerals that might not be technically rare in nature, but it's not evenly distributed across, and it could be hard to find. So when we say the word rare, there's a couple of connotations to think about. Rare could mean that it's there. The tonnage is there. We just have to kind of find it. The other reason it might be rare is how to find it could be very difficult, and then to get it out of the ground, the process of pulling it and extracting it and refining it and getting the mineral could be very, very difficult and time consuming and very, very energy intensive. So it could be rare that way as well. All right. So when we think about these ideas, we can think about, if you look at the map in the United States over here, just scan around, and from the northeast to the southwest to the southeast to the northwest, our country is laden with minerals, and where do we go to get the things that we need? All right. And then the idea of a metal. All right. Well, metals are minerals that are generally malleable and often conductive, such as things like gold and aluminum, or nickel. These type of things are pretty malleable under fairly normal conditions. Okay, but if you look at a quick diagram here, you can see that a bunch of these minerals are found, and resources are found within your home literally right now, or if you're in an apartment as well. Without reading through this entire list, you can read through, look at your areas of interest, but look at the electronics. Gold is pointing out right there, neodymium, okay, silver, construction materials. Here's a good one, concrete, right? How many of you have driven down the Florida Turnpike and seen all the huge concrete processing plants off in the distance, right? That's what they're doing. They're making stuff to build. Right, so looking in your home, all the wirings and copper pipes and your paints have cobalt and fluorite and sulfurs and things in them. Old light bulbs, your incandescent light bulbs, used to have things called tungsten filaments in the middle of them. Hopefully now you have compact fluorescents, which are much more energy efficient. Appliances and tools are covered in things like iron and nickel and zinc or aluminum. And your cars even have lots of different types of materials. So society relies on many mineral resources. Some are a little bit more familiar than others. Some are a little bit tougher to even pronounce. And so in that respect, people know even less about them because you can't even say them, right? Some of them are kind of tough. But they're there, okay? And so where do they come from? This is some of the geologic process behind some of the mineral resources. If we took a slice out of the earth and we could see into the earth, which we can't, but if we could see that the earth was differentiated into different layers, and this is basically due to something called gravitational differentiation, which basically separates the inside of the earth into sort of distinct layers based on density of materials and substances that creates these particular layers. So we live on the crust, which is over up labeled right here. This little tiny edge right here is the crust, and that's what we live on. And keep in mind that 2/3 of that crust is covered in the oceans, and so we can't even live necessarily on that. We're living only on the land terrestrial part of that crust. All right. And so this is kind of an outline of what it would look like in the middle. Some people sometimes ask me, hey, if we can't take a slab open of the earth, how do we know it looks like that? That's a great question, and that's one question that you should ask. Well, you can do this through something called geophysics. We can look at the different types of seismic wave activity. In fact, we use earthquakes oftentimes to measure distances and thicknesses of the speeds that sound waves propagate through the earth as a result of earthquakes or even atomic explosions and things like that. Again, we're not going to spend a whole lot of time on this, but just really to understand that the accessible minerals are in the crust, in the lithosphere, okay, where we are. Remember, here's the lithosphere, all right? And that's where we need to find everything that we need, just on that. And the deepest mines that we even have are barely 5% deep into this little tiny stretch of terrestrial land right there. I mean, imagine just, whoop, that's it. Right? I mean, we're tapping into almost nothing in comparative thickness to the earth. Okay? So that's the idea here, to think about where we get these things and why it's so intensive to get them. Now, sometimes Earth can help us out, and the geologic processes can bring materials from the upper mantle into the surface. Or volcanoes, for example, can eject different materials down from this area here, where the magma flows and gets pressurized up through these volcanic vents as a result of moving plates, tectonics, and the melting of a subducting plate here in a subduction zone, for example, and up through this volcano, and sometimes can eject materials that we need. Also, the intensities and pressures found inside of here can create some minerals that are very highly sought after. For example, we find diamonds there. So we're not going to spend, again, a whole lot of time on this, but that's kind of what's happening here. All right. This picture shows you that the tectonic plates that cover the earth, which basically, if you think about a patchwork soccer ball, something like that, each patchwork is kind of representative of a plate, and they're kind of moving around the earth as a result of tectonic motion, and that's kind of what's making these minerals and rocks and things form around the earth, okay? But if there's one thing that you can take away from this is that we live on the lithosphere. The lithosphere is the places that we are mining to get these mineral resources, and that volcanic activity can release the minerals on top of the Earth's surface, albeit it might be covered by millions of years of something else, but we could get it. The tectonic forces are also driving these plates into different ways in which will create mountains, so it can thrust up many sort of layers of Earth into the air, and therefore we can access some of those layers of the Earth that were geologically ancient, but were only exposed to the planetary surface for us to get to based on some of these plate tectonics and the movement of the Earth's surface. If anyone's ever been in an earthquake or heard of an earthquake, this is a direct result of these plates moving in respect to one another. So that's kind of the takeaway for this part, is if you can understand that in terms of what to know about geology and tectonic plates, then we're doing okay. And if you look down at something like right here, this is where, right, you'll find some of these minerals and things like this. Like you might have a gold thread in here that we'll have to mine down, go get, mine it out, process it, and bring it back. Okay. So the minerals are the basic building blocks of those rock that are creating the Earth's lithosphere that we're standing on and mining into. Okay, so all the rocks are made up of these things, and if we look carefully at this example of our gold thread again, we can see that all this other stuff, it may not be very economically valuable for us. We have to drill down somehow or mine in there, go get this gold, mine it out, and then replace it somehow, and all do it environmentally safely and safely for the mine workers, so we don't have a mine collapse like we had in Chile a couple years ago where the miners were stuck down there for days, well, months. All right, and yes, gold like this. We do all hopefully know who Flavor Flav is. The gold grill on his teeth come from these shreds of rock right there. They are mined and brought up and used as a sign of affluence, including his gold earring as well. His diamond earring as well. So anyway, to move forward, the rock cycle is just this process that creates different types of rocks and found within the lithosphere of the Earth. We're not going to spend too much time on the rock cycle, so I'm going to let you read this on your own for interest, but we're going to keep going because not quite the focus. The book spends a couple of minutes on this, but we're not going to spend too much time. What we do want to know is what this idea of an ore and mining is, okay? So when we have this rock cycle occurring, it is producing all kinds of different forms of minerals and combinations that form rocks that are subjected to different heats and pressures and times and erosions and weatherings and repeat over millions of years kind of thing. And it's producing all these different kind of rocks. For example, granites, or we have feldspars, or we have, things like shale and mica. I mean, I'm not going to sit here and list off all the rock types to you, but there's lots and lots of rock types, and there's different ways in which they're formed. But when we have metal minerals that are put together enough in a particular set of rock through these geological processes in the rock cycle, there might be enough in one place that might be economically viable to mine it. Okay, so you're not going to set up an entire mine to go down and find 2 grams of titanium, right? That wouldn't be very economically responsible. But what we need to do is find out where are these concentrations of these ores, of these minerals that are making up these rocks, because then we can go down and get them. And so that's what's happening here with how the rock cycle kind of connects to this chapter. All right. When we want to do so, and we want to go look at some ore, and remember, ore, to go back, is that concentration of economically viable material within the rocks. Okay, and we want to go get that ore. All right, we have to do and perform some extraction processes, and it can be very damaging to the environment, or it can be very damaging to, could be damaging to the environment and humans, or all of the above, however you're viewing the ecological profiles of your neighborhoods. But when the ore is relatively close to the surface and it's shallow, or say, for example, a horizontal deposit. So say the ore was laid down as a layer of something. Then strip mining comes in. And you can see in this picture that these mountaintops would have connected all the way to these tops here, like this. I mean, this is not found how it was in nature. Man has come in and carved this out to get those layers of ores that we need. And additionally, they have to build roads to get the trucks in there to get the mine and ore out back to the mine. Okay, so the problem here is the overburden is removed. So say if you have this area and you want to get something underneath this area, you got to get rid of this area first so you can get down there. Okay, it's kind of like going to dig up a an old septic tank. First you got to dig through your lawn and your grass and then get down through the dirt until you finally get to the thing that you're interested in. The overburden in this case is forests, and we know from previous chapters that forests play a crucial role in the development of and sustainability of an ecosystem here. But to get to what's underneath it, there really is no other way than to remove the overburden, extract the ore, and then replace the overburden. I mean, that's the law now. They have to go back and replace what they took out, but it's never the same. Okay, it's kind of like putting a patch over a place that you mined out. These forests are hundreds or thousands of years old, and replacing it with some new saplings isn't quite exactly the same thing. But revegetation and restoration is needed and required, and they do so. And how well they do so is monitored by the mine companies and their overseeing agencies, EPA and others, USDA, agriculture. So mines are frequently of this type, but if it's not a if it's not a horizontal layer of ore, then it could very well be vertical, or it could be like a 60 or 90 or 30 degree or something, like the vein through that goes down into the earth. Then they got to do something called open pit mining. And open pit mining is kind of where the ores are fairly deep in the earth. You can see that it's not just a line carved in the side of the road here, the hill here. It's deep pit mining. I mean, look what these miners have done. They've dug all the way around, and you can see these little tiny lines, right? These are all little, well, some of them are roads for the big trucks. Other ones are just blasting zones where they're blasting material out of the earth. Dug out, used heavy equipment to haul back to the surface. Say over here, there's these trucks. These trucks are enormous, by the way. They're the size of a house. And these will bring the ore back to the processing plant, and then it's often shipped off to different places. Things like copper are mined this way, fairly deep mines. Okay. So when you look at some of these mines, and for example, there could be heavy metals in sedimentary materials, and they're recovered using place mining techniques. Okay, so you have these kind of mines in this area, and the sediment-laden material is drawn through water. What's called a sluice. This word over here, it's called a sluice. Gold also is produced this way. So gold is a heavy metal. Okay, so this is a different mining technique where all these people here just kind of, in this area that's thought to have gold deposits in it. And what they'll do, and this, by the way, is the same thing they're doing in things like Gold Rush Alaska, or those TV shows you might have seen, is this material, this earthen material, will be run through a sluice or panned for gold. And when you do so, the heavier materials or heavy metals will get trapped in the bottom. And so what you'll end up having is a trapment of these heavy materials on the bottom of some of these pans that they're sloshing around in the water, and the water helps separate the lighter materials from the heavy materials. And therefore, when you do the proper technique and finally get it all done, you can see a bunch of these trays over here. Gold dust, literally specks, sometimes maybe a small nugget, is left behind, and that is collected. So different way, definitely different from strip mining, open pit mining, to sluice mining, different ways of getting the material out of the earth. The other way that it might be a bit more known through sort of pop culture or in the news is straight up shaft and tunnel boring through mountains, underground mining. Okay, this is kind of what some people think of a more quote-unquote traditional miner, the guys with the old lanterns on their helmets walking in to go through the mine, or in the Indiana Jones or something where they're going through the mine shaft. These ores tend to be very deep in the ground, and they require extreme burrowing through the mountains or deep underground. In this case, there's no light. All light is artificial, man-made, has to be pumped in through batteries and power. Fresh air has to be pumped in. Power and energy needs to be pumped in, and the ore is dug out and brought to the surface through this particular fashion. Very labor intensive, very, very hard work. I mean, they're all hard work. This is indeed very hard work because of conditions. These guys are down there for 12 hours, maybe 16 hours a day, without even seeing light of day. You don't even know what time of day it is, really. And gemstones are really mined this way. I mean, they're down there looking for diamonds, looking for rubies, looking for all those things that we want to put into jewelry, okay? And other things that we need because, you know what? Jewelry is expensive. Gold grills are expensive, right? That's why people like to show off their opulence, or their affluence, I should say, with jewelry. That's what they did way back from the Egyptians and beyond, or whenever they used to use this stuff to show off their wealth and power. All right. So to use this, looking at this material right here, this diagram, you can see kind of what goes into getting these minerals and materials out in terms of mining. Okay. Heavy equipment is used to obtain the ore and the waste rock. And there's also processing energy that requires a lot of voltage or water or chemicals or acids to dissolve away things. And these go into processes such as digging out, crushing and grinding, separation of materials, things like smelting and purification. These are all part of the manufacturing process of getting minerals from the earth. Okay, what's left behind, waste rock, is left over. Some of this stuff is radioactive, so it needs to be stored in radioactive containers, pretty much in Yucca Mountain right now in Arizona, or in the Southwest is where they're putting a lot of this because of the air and the climate there. Smoke pollution from the air stacks coming out from mining and refining all of this stuff. You know, if we have to smelt things down, which means melting of minerals at high materials to purify. And then there's hazardous wastewater, and that either has to be stored and purified, or somehow it might leak back into the groundwater supply, like you may know the movie Aaron Brockovich. This is what all this was about. The point here is that energy, right down here, energy and resources needed to move and operate and power heavy equipment are extremely resource heavy. Okay, rock and material does not break down very easily, so you need a lot of energy, a lot of input energy to get output. Okay, and that's really what it's all about. Input equals output, right? The basic economic model. So that's what we're saying. Well, what does this do to the particular areas of the land in which all these men and women are working? Well, of course, there could be habitat damage. Road building, deforestation, water pollution, loss of soil are all consequences of mining, and the waste of all that rock can be contributing to different stuff. Big pile of huge rocks where was once lush forest is a different type of ecosystem. Okay, could also cause some acid rain as rainwater percolates through these waste piles and pick up some more acidic compounds and filters back into the water system. All right. Of course, the air pollution coming from the smelters and the heavy equipment in terms of the exhaust from the diesels and the air pollution to run the equipment, the graders, the tractors, the everything else, increases the carbon footprint, okay, of this particular operation. Mercury pollution is another big one that can come, especially in the extraction of gold and silver, because it results in substantial mercury contamination in areas around the mines, especially in downstreams if this mercury is entered into the groundwater cycle, which could then enter into the drinking water even, or end up into the oceans and into our fish stocks. okay, depending on where this stuff is done. All right, the acid mine drainage. This could be extremely sulfur-containing rock that could be chopped up, mineralized, powderized, whatever, and that could be mixed up into the water systems and certainly damage the ecosystems around there. And then, of course, it can be transported down river systems to the fish streams and anything that eats those fish in the streams and beyond. So the bottom line, the carbon footprint in the mining industry is extremely intensive. The energy used is enormous at every stage of it. I mean, even just the men and women in the mines, you might think, well, it's just a couple of people in the mine. No, to get those mines the way they need to be, safe and large enough for them to work, is extremely intensive. A lot of energy goes into it for a little bit of output. Okay? In order to help mine and refine these mines and materials and resources that we're pulling out, we have to use toxic chemicals sometimes to process the minerals. And that could be hazardous chemicals. And if it's done in an area, it could be a potential threat for a quote-unquote meltdown if something catastrophic occurred, or if it's done in places that don't have the same regulations as the United States does about operations of mines. So these toxic chemicals could just be being poured off onto the side of the forest or the stream to get away from it. If no one's watching them and they don't get in trouble for doing it or imposed any fines, they don't have the resources to refine and take care of these chemicals, so they're just going to dump them out. I mean, there's little economic value for them to keep it. The economic value is not in the processing of the hazardous chemicals needed to get those gold and silver and platinum and things out of the ground. It's the gold and silver and platinum that they need to get it. So that's why they may not necessarily be so interested in spending all this money if they don't have it to take care of that toxic chemicals. And of course, that could lead to polluted environments. Okay, so the polluted environments could essentially end up in agricultural areas from runoff, especially in the Midwest or the Southwest, where these things are occurring all the time, and end up kind of reducing or even killing livestock or crop, and that's damaging the farmers. Basically, economic resources that's indirect from the mining operations. There's lots of movies and case studies about this stuff, so I encourage you to take a look. The other thing is thinking about how this stuff is done. Well, it's basically done by men and women working in these mines. Well, in places where economic status is a very difficult thing to come by these days, child labor is becoming an increasingly big problem, and where children are being forced to earn money for the family somehow. And if there's no education and there's no agriculture in the area, then mining might be the alternative. And if they are a set of hands with a strong back, they can be involved in this and make a few bucks for their family, whether or not it's considered morally right or not. If they got to feed themselves, they might be doing so. In the United States, we have laws against this. In other places, they may not. It's also very dangerous. If you put someone down there who's not educated enough in the safety of the mines, you easily can set yourself up for a recipe of death and disaster. Okay? So in continuing then, if people aren't performing these operations and impacting the ecosystems and performing these mining operations, well, there ought to be some sort of social issues surrounding this, and of course there is. There can be displaced communities. There could be, think about West Virginia right now and the coal mining that's happening, where they're lopping off all the mountaintops in West Virginia to access the coal that the country needs as a reactant to overseas oil. So, but the people that live in West Virginia don't want this to happen because that's their land, that's their backyard. So, check out that idea. There's also a movie called October Sky, which is an interesting movie about the son of some farmers. And check out this documentary that used to be on Netflix. Now you have to buy it, but it's called Coal, literally coal. And it's all about communities around these particular kind of mining entities, and how it can be displacing communities, how farmers can be bought off to have their land accessed by miners or oil miners. What does that do for for the mining, for the family, to the community, all this and that. And of course, there's violence as a result. If kind of two heads are beating against each other about what to do with the particular land, violence can occur. It could be violence over the operations in the mine, especially when it comes down to things like blood diamonds. You may have heard of these diamond mines and people getting their arms cut off when they try to steal one diamond to help feed their family. Okay, there's lots going on in the mining field in terms of social processes. But what happens then when we have all this stuff and we now need to we've made it and we can put it into our materials and we use the materials, and then what happens when we're done with it? All right. Well, there's an idea called e-waste, and what e-waste really is the waste of electronic materials that are reusable, but they're just not being reused. Okay. So this e-waste is how plastics and metals are basically being combined now to be reused. There's a new kind of subfield that's not really a subfield, but it's a more directly it's a field that's becoming kind of in more focus, if you will, because of the access to electronic waste. Okay, we know that many of these electronic materials have resources in them that we need, but now instead of just throwing away the keyboard, for example, or an old cell phone, these things are being specially reused. And claimed so we can pull resources out of those materials and use them into new materials. Okay, so one advantage to mineral resources is that while it's not renewable, they're a lot of times reusable. Okay, gold doesn't go away. You don't use up the life of gold. You can melt it down and remake it into new things. The same thing with plastics and aluminum, like we do with cans. In our milk cartons and things like that, resources that are into electronics and things like gold or copper wiring or anything else can be reused. And this is kind of a new reclamation act that's happening on a small scale level. People are actually hoarding old cell phones now and trying to prop them open and collect the resources that are inside and take them for recycling, and they get money from them. And you can do the same thing. So we can minimize the impacts of mining through kind of conservation strategies. If we think about if we set up a reclamation program, we might not need to pull as much mine and ore out of the earth. If we already have it pulled out, let's just kind of keep using it, right? So that will stop us from having to produce as much of the original ore. However, the more products and the more people we have in the earth, the more we will need. So the more we can reclaim and the more we can put back into the mineral cycle that's already in use, the less we'll have to possibly go out and mine, the less we're going to have to crush and process, and the less we'll have to smelt. And all of that will use less energy. And so that's kind of the idea. Recycling is this main issue, is how can we recycle the current supplies and reduce the need for new raw materials. Cash deposits and redemption refunds have significantly increased recycling rates in the United States. And it would seem that 5 cents recycling on the aluminum can, that's made recycling big business, believe it or not. Yeah. So here's the idea of recycling. I don't think this is new to anyone here in this course, and we're not going to spend a lot of time. But take this idea and think about how we can recycle the materials that we pull out of the earth. Okay, instead of getting new aluminum ingot, we can form new ingot from existing ingot and form new aluminum cans and materials. We can do this model for almost every element that we have, mineral we have. However, each mineral process is going to be a little bit different, right? The same way we reduce aluminum is a little different than we might reuse gold. So those processes are different, and those processes are becoming quite mainstream in how we can do this in a sustainable method. So the best practices in mining comes with ideas of processing what we already have, and then bringing in new technology that will be more sensitive and safer, so we can find these mines which might be more easily accessible to get us the ores and things that we need. Remember, if we need less of it, we need to find less of it in the earth. If we need to find less of it in the earth, we can use more technologically advanced processes to find smaller deposits that might be more accessibly mineable from that perspective. So improved mining technology may allow for more efficiency and higher yields from the same ore. If we can get more crop out of that rock that we want, the more efficient that ore deposit is. So as the value increases, more deposits become economically viable. For example, previously abandoned gold and silver mines in the United States could be reopened because of the less efficient methods of getting the ore out before can now be reused and put back into service, because we can kind of go in. It's kind of like, rolling that toothpaste bottle from the very end to squeeze all of that toothpaste you can possibly get out of that possible toothpaste tube. Okay, imagine if you just had the toothpaste, it was kind of done. But then your wife or girlfriend or someone walks in and said, come on, you're wasting this, you can squeeze more. That's what we can do. We can do that and kind of get more efficiency out of that toothpaste bottle or out of that mine. With the increase in value, the previously abandoned sites or toothpaste tube are again economically productive. And so it's kind of like almost saving money. And that's big business to the mine owners, because if they can make more money out of this one mine, then they don't have to invest the capital into opening new mines, which will then actually reduce their operating costs and increase profits, or possibly drop the price of the particular ore that they're selling. Okay? So, moving forward, the extracting and processing materials from waste materials reduces the need for new materials. Okay? That's kind of where we're at. Where is this stuff found? Well, that's going to be up to you to go and look at some of your discussion forums to see where some of these things are, what are some operations happening around your communities to see what's going on with recycling of mineral resources already in use. I've been harping on cell phones because that's a great model, because it has so many materials in there that can be recycled. It seems like such a small amount, but it can be recycled. Remember, there's strength in numbers. My cell phone and your cell phone plus all of our cell phones plus all of the cell phones in the country will add up to lots and lots of resources. We also have to think about consumer conservation, and what are the initiatives out there in which we are trying to deliver ourselves from a throwaway society? How can we reuse things to make sure that the next cycle of product takes into account some of the previous cycle before it? Okay, so wouldn't it be great if we can make our cell phones that are composed of previous cell phones materials? That would be great in all ends. And we can think about, instead of being a throwaway society, we can be a consumer conservation society where we have a culture of reusing and reducing materials that are what we need for our society to advance. Remember, we do want to advance technologically as a society. How can we do it smartly and efficiently? Okay, we can minimize efficiency by using different materials from before. Many internet companies are now switching to fiber optic cables because of their efficiency. You can carry more information instead of the copper wire that's used to deliver your internet signals. Yes, I get it. Many of you are wireless, but those wireless signals come from previously wired systems into wireless routers or wired cell towers or whatever. But fiber optics are being built into the ground, and which are a bit less expensive because they're basically made from glass, which is a component made from silicon dioxide, essentially, which is sand, right? So talk about getting that resource. Go to Miami Beach and pick up a sample of that instead of digging down 2 miles into the earth to get your ore. Okay, so obviously there's many things you can do. There's individual steps. Help recycle your rare earth materials. Many stores have cell phone battery drop-offs, recycling places. A school looks for them. Donate your old computers to charity, or old computers to schools, or old cell phones to women's shelters or homeless shelters, to people that need emergency access to phones. That's something you can do. You can organize group actions. You can look on your campus or citywide initiatives to purchase electronics who have conflict-free resources, such as certified non-blood diamonds or certified non-child labor, gold ore deposits. Sponsor collections for permanent sites in your community to collect cell phones. Hey, you know what? If you don't end up taking the cell phones, you could probably mine them yourselves and get all the gold and material out of them yourself. Or you can get cell phones for soldiers and help send veterans and active duty military members prepaid phone calls, prepaid cell phones that they'll ship overseas so they can make phone calls back to their family. All these things you can do, and they're little parts of society and our community that are working to make things more sustainable and efficient from the term of material resources. And of course, if you really love this stuff, you can get into policy change, look into the health and safety of the mining administration. You can contact your policymakers or yourself if you want to go into things like the USDA or economic policy on mining. I mean, it's big business. You can do well, make a lot of money, but you got to take a lot of courses in mining and economics and stuff like that to really understand what does it mean when things happen in mines, not from just the mining, day-to-day operations, but from a policy, long-term policy thing. What happens when people get sick, get black lung from being down in the mines so long, and they won't be supported by companies or can't get health insurance or things like that. So there's all kinds of things going on. And I'll close with this picture again, just to remind you. These guys all have gold sluices in front of them, trying to find those gold products to use that you very so much love, like your cell phones or your gold earrings or even someone's gold grills, all right? But the point is, think about your resources. Think about those who are married or getting engaged, or your diamond rings and where they're coming from, and are they certified, and everything, all of the above. You can do this. Okay. Hope you enjoyed this one. I'll talk to you soon.